guys, so today I'm going to do a brief video on the quotient rule and using the quotient rule to find derivatives of functions. And as you guys see here, I have written the formal definition of the quotient rule, but it does look a bit complex. So I'm going to show you guys a simple and easy way that kind of rolls off the tongue to remember the quotient rule. And I like to call it low D high minus high D low over low low. And here the D essentially means derivative, and I'll kind of show you what I mean with an example that we can walk through together. Alright, so for number 1 here, I have y equals x squared over 3x minus 1. Alright, so you'll notice I have one function on the top, right? So I'll call that high, because it's on the top, it's our high function. And I'll call this function on the bottom here our low. Again, pretty intuitive because this one's on the top and this one's on the bottom. So you'll notice here, right, we have one function over another. So that's your cue to kind of use the quotient rule to find the derivative. So let's go ahead and find our y prime. So we're just going to go ahead and apply this rule right here, the quotient rule. So again, a y prime equals low. So our low function here, so 3x minus 1, times d high. And again, d means derivative. So this essentially means the derivative of our high function. So derivative of x squared would be 2x by the power rule. And we have a minus our high function, which is x squared, times d low. So again, the derivative of our low function. And again, using the power rule, the derivative of 3x minus 1 is simply just 3. All right, and that's all over low times low. So that would be 3x minus 1 times 3x minus 1. Okay, so that's basically your setup. Now all you have to do is simplify this. So just to make a little bit more room for myself, I'm gonna erase my problem here. All right, and just simplify this down. So y prime is equal to, distribute this through. So we have a 6x squared minus a 2x, and then minus a 3x squared on the top, over, and then we're just going to same way distribute this one out, right? So we're going to have a 3x times a 3x, which is a 9x squared, minus a 3x minus another 3x, that's minus a 6x, and then plus 1. Okay, then just cleaning this up just a little bit more, we have combining like terms. So 6x squared minus a 3x squared gives us a 3x squared, and then minus our 2x. And the bottom is already all set to go. Can't combine any more like terms. So, and there you go. That will be our derivative using the quotient rule. And again, you could have just left this bottom part as 3x minus 1 squared. If you didn't want to FOIL it out, it's all the same thing. Up to you. This is the most distributed form possible, but all answers are acceptable. All right, so we'll walk through one more very quick, simple example. So I have here y equals 2 over x plus 1. And notice here, right, we have something in fractional form, or in other words, one function over another function. So again, that's your cue to use the quotient rule to find the derivative of this whole thing. So we'll just call this one our high function, and this one our low function. Okay, and we're all set to take our derivative. So y prime equals low, which is x plus 1, d high, or derivative of high, derivative of a constant is 0, minus high, which is our 2, d low, or the derivative of x plus 1 right here, which is just 1, over low times low. So x plus 1, x plus 1. All right, and we'll just clean that up there. So this whole part right here gives us 0. So we have a negative 2 left on the top, over, and here I'm just going to rewrite this as x plus 1 squared. Again, you can go ahead and distribute this out if you would like. but I'm not going to do it for time purposes here. But this would be our derivative using the quotient rule. Alright, so that's it for the quotient rule. Just remember low d high minus high d low over low low. And you guys should be prepared to solve any quotient rule problem. And I also have another video in which I do some practice problems, specifically these right here. So feel free to give that a look. I've linked it in the description below. And if you guys found this video helpful, please give it a thumbs up. I really appreciate it. Hope this helped, and see you guys soon.